So hi guys, myself CA Srinivas. I welcome all of you to this wonderful subject called as strategic financial management, which of course is an 100 marks paper, and it is very scoring among all the 4 papers in your group. So let me give you a small introduction of what do we have in this subject SFM for your CMA final level, because in your CMA inter you have covered a certain level of financial management already. So this is an extension and a much more advancement of the financial management concepts. Now, even though the CMI final curriculum calls this paper as strategic financial management, ideally looking at the contents of the subject that we have in our syllabus, ideally it should be named as corporate finance rather than strategic financial management, because when you go through all the questions, all the chapters, and all the applications, you will understand there is definitely financial management, but where is the strategy? So, how is it strategic financial management? Of course, there are a lot of strategies, there are a lot of plans, actions, and all, but typically the subject, whatever we are studying at international level, it is called as corporate finance. Now, what this corporate finance subject tries to address is, if you are a financial manager in a real life company situation, what are all the challenges, what are all the situations you will face, and in those situations, how to take a decision. So, how to take a decision, what is your objective of your taking decision, and arriving at that decision, how to do the analysis part. This entire subject is all about that. So, if you see the contents or the broad chapters what we are having, so your entire thing is divided into total 5 sections, sir. Section number A covers investment decisions. Investment decisions, in a very simplistic manner, if I should tell you, this is a glorified version of capital budgeting chapter. Did you have it in your CM Mentor? Capital budgeting? Yeah. That NPV calculation, IRR calculation, those things are again there. Not only that, there is a further application called as risk analysis in capital budgeting. So that is little heavier, but that's not tough, easy only. So broadly it is that. And apart from that, there is leasing decisions, which is also very, very popular and an important chapter from an examination point of view. So broadly, this entire section A deals with capital budgeting and leasing. And then there are a couple of theory chapters. For example, if you take securitization, securitization is a pure theoretical concept. There is nothing much in that, but as such, it is easy only. So, investment decisions is one thing. Second thing is security analysis and portfolio management. Now, this is one section. You can look at the weightage of the marks also. The weightage of the marks is 35%. And since looking at the weightage, you can easily guess the content or the coverage of this particular section is the most elaborate one. It will take a lot of time in finishing of this also. In this, you see, forget about the chapter names what they have given, but broadly what you will be having is portfolio management. This is all about portfolio management and share valuation and bond valuation. So this particular section is all about how to measure the worth of the share, how to get the value of a bond or a debt instrument, and you are having a portfolio of various investments, how to manage that, what are all the various statistical applications of that. So this is about that. For example, if you see this portfolio management, this is something which is very, very heavy. I mean, in terms of the content and in terms of the formulas also. Tell me, sir, do you like formulas? You like? Don't like? No feeling? You like? Then you will be having at least bare minimum some 30 formulas minimum. Proper statistics formulas. But as such, there is a soul to it. It's not like I give you a formula, you somehow by heart it and blindly remember certain formats and apply. It won't be like that. Definitely won't be like that. There will be a lot of soul into it. You will understand why a formula is looking like this. What will happen if I change this? Can I do it in any other way? All that insights you will have. So that makes that chapter very interesting. And trust me, it's very scoring as well. And of course, I forgot to mention, even mutual funds is there. Yeah. So broadly, section B is about these 4 chapters, sir. Next comes to derivative instruments. The section C is about a unique concept called as derivatives. So derivatives is supposed to be understood as one of the most difficult concepts to understand for most of the students. But you see, sir, organically when you learn step by step, understanding each and everything, and you do your side of the work every day, then definitely there is nothing which is difficult. Okay. So there is one good news in this. That is, derivatives is not connected to your C inter syllabus or your basics or your practical applications, nowhere. This is something which is totally new, introduced at CMA final level. If something is new, it's like a fresh start for us. We don't ask any background for that. So whether it is difficult or easy, what people say, don't bother about that. We will handle in our own way. And finally comes Forex. Again, from a weightage point of view, if you see, it's around 15%. But if you look at the number of questions, what we have only is around some 80 or something like that. Like very, very vast chapter, very, very interesting chapter also. So that is about Forex. And finally, section 5 is the digital finance. This is a small theoretical chapter. That's not something which will trouble you basically. So if you see section A, investment decisions, section B, the share valuation, bond valuation, and section C, when you see derivatives chapter, in these 3, we need application of time value of money concepts. Now, time value of money is something which you might have learnt in your inter level. So, how good you are with your time value of money concepts? Good, reasonably good, extremely good, poor, negligible, left in choice. So, depending on that, how good you understand time value of money, how good confidently you are willing to make that effort, like, and try out all the questions and applications of time value of money, how good you are in time value of money, that will determine how good you are in entire SFM. Entire SFM ka blood is time value of money. Once you understand time value of money properly, and then 1 or 2 small chapters from the moment we do, you will understand, you'll start writing formulas on your own. You'll never ever by heart any formula. All the formulas you can casually write. So once you understand the logic of the formula, once you are able to see through the formula, then why do you need a formula sheet to by heart something before the exam day? So we will eliminate that requirement. So what we will do is, before we start any of these chapters, I have curated a small chapter for you, which broadly is time value of money. But apart from time value of money, there are certain other concepts as well. So once we finish off this chapter, you will be in a position to have a proper application of time value of money. Not only that, certain insights into some concepts of NPV, IRR, valuations, these idea also you will have. Once we are ready here, mathematically and conceptually, then we can start any chapter. There is no particular order required for us. Any chapter, whatever, I'll give you some options. You select one chapter, we'll start off. Okay. So here, welcome to a very, very small chapter and a very beautiful chapter called as time value of money. There are only one request in this. Many people have a small stigma about this chapter, that this interest compounding and all, we do not like it. That kind of resistance some people have. I have observed it over my years of experience. So shun that. If you have any problem with time value of money, please feel free to ask, and willing to make mistakes in this. Try on your own. If mistake happens, let it happen. Okay, because unless you learn originally, subject can't be done, sir. Okay, so let's start. So the concept of time value of money goes like this. Suppose, sir, this is my timeline. In timeline, whenever I write 0, you understand that I'm talking about today, right now. When I write 1, it means it is at the end of first period. That first period can be 1 year also, it can be 6 months also, it can be 3 months also, but generally it is 1 year. If it is 3 months or 6 months, I will tell you. So this is called as timeline, sir. 0 means it is now. And here I am telling you this is at 1 year time. Now, if I give a choice like this, to receive 1000 rupees today, or choice 2, receive 1000 rupees 1 year later. Between these two choices, which one will you take? 1000 now or 1000, the same 1000 after 1 year? Which one is better for you? 1000 now. Why? Because if you take 1000 rupees right now and invest it somewhere, then after 1 year, the value of that investment will be more than 1000. No matter how small the interest rate be in the market, still the future value of 1000 rupees today is higher than 1000 rupees after 1 year, correct? That means the conclusion is a choice one, whatever 1000 rupees is there, if you reinvest for 1 year, sir, at what rate? Whatever rate is prevailing in the market, wherever you invest. At least bare minimum rate is what? Risk-free rate. Risk-free rate is what? The rate which government gives on treasury bills. Treasury bills are not issued to individuals like you and me. So for us, let us consider a basic bank rate. Okay, on a normal bank deposit, how much rate will you get? Let's say 8%. So my 1000 rupees plus 8% will become how much? One calculator, 1000 plus 8%, 1080. 1080. So from this, what you can conclude is the value of 1 rupee today is more than the value of the same 1 rupee after 1 year. Clear, sir? So what does this prove? This proves that value of rupee 1 today is higher than value of rupee 1 a year later. So it's like this, sir. Some student wrote exam in June. He will, if he passes in June, or if he passes in next attempt December, will it make a difference or not? Purely in monetary terms. Ultimately he will pass anyway. He is destined to pass. It's just a matter of when is he passing. The earlier you pass, the better it is. Why? You did not study anymore. Huh? You can start earning, right? Likewise, 1 rupee if you receive today, 1 rupee you can invest somewhere. That somewhere will give you some income. The investment plus the income put together will be higher than 1000 rupees a year later. So definitely 1000 rupees today is better than 1000 rupees a year later. Clear clarity is there? Now from this what we are proving is money has a time value. What we know, money has a value we know, because with money we can buy so many things. Money has a time value means time value is nothing but the interest part. So you receiving 1000 rupees today is completely different from you receiving 1000 rupees a year later. The timing of the cash flow matters. So this is also 1000, this is also 1000, agreed. But the timing of the cash flow not same. Therefore their values are also not same. Am I clear here, sir? So this is first point. Second point, sir. If you want, you can write this, or if you can't write and listen also, then only listen. As such, concepts are there in the book. Concept booklet is there, questions, everything is solved. So you need not compulsorily write, but my past experience suggests that if you write, that will keep you alive in the subject, number one. Number two, you will start thinking. So exceptionally rare circumstances, do not write. Try to write as much as possible. Because of that, you will stay along with me. That's all. Okay. Listen, second conclusion that comes is, now sir, you all told me that you will take choice 1 only and not choice 2. How did you know? 1,000 rupees you have projected it into future, and then you compared this versus this, correct? Now you tell me, did you directly compare this and this, or 1000 versus 1080, 1000 versus 1080? That means unknowingly, knowingly, you took a decision by comparing cash flows standing at the same point of time. Actually, in the two choices I gave you, 1000 is standing at 0 time, another 1000 is standing at 1 year time, but you did not compare 1000. What did you do? 1,000 rupees you projected it into future. You took 1000 rupees in choice 1 to 1 year time, and you compared that 1080 with the 1000 rupees in choice 2, which is already standing at 1 year time, and then you made a decision, correct? So choice 1 is projected into future, then only you are comparing. That means that comes to our second point here. For a decision making, based on cash flows, ensure that cash flows are standing at same point of time. It's a very, very, very important principle. Cash flows comparison, definitely you must ensure that they are standing at the same point of time. Sir, but they are not actually standing here. They are standing at different points of time. But what you do on paper, move the cash flows across the time. Okay, future cash flow, bring it to today, or today's cash flow, take it into future for comparison purposes. Now for that, what do you need? You should know how to take a present cash flow into future. You should also know how to bring a future cash flow into present. Moving the cash flows across time is required. For that, we have to learn the techniques of compounding and discounting. Broadly, compounding is nothing but converting a present cash flow into future is called as compounding. Already what is standing in future, that if you bring it to today's value, it is called as discounting. Why this movement is required across timelines is this purpose. One more point also you can add. Even for addition and subtraction of cash flows, we have to ensure that cash flows are standing at the same point of time. So if cash flows are not standing at the same point of time, you cannot compare them, you cannot add them, you cannot deduct them. So when you consider the impact of time value of money, you cannot add cash flow standing at different points of time directly. You cannot do that. Now, just a small reminder. In your CIMA Inter, you have studied one small technique called as net present value. Do you remember the formula by chance? This is present value of your future cash inflows minus present value of your future cash outflows, or present value of simply cash outflows. Now, what is the interpretation of this formula and all? Later on we will see detailedly. It's part of our discussion of this chapter only. But before we go into that, visualize this. Today, I have to buy a machinery by spending an amount of 24,000 rupees. If I buy this machinery, then first year, second year, third year, I will get some cash inflows. Those cash inflows are, let us say 10,000, another 10,000 here cash inflow, another 10,000 here cash inflow. Let us say discounting rate is 10%. Now, The question usually asks you what? Can we buy this machinery or not? Can this proposal be accepted or not? This kind of questions only will have in capital budgeting. No. So how will you make a judgment? How will you make a decision? NPV calculation. See, first and foremost, this is also 10,000, this is also 10,000, this is also 10,000. But are they standing at the same point of time? No. Is the amount same? Amount is same. Is the value same? Value is not same. Why value is not same? E 10,000 is standing at 1 year. E 10,000 is standing at 2 years. This is standing at the end of 3rd year. So tell me, sir, out of these 3 10,000s, which one is having more value? All are, sir, all are same. No, sir, all are amounts the same. I'm asking value who is better. The first 10,000 is obviously having a higher value than second 10,000, and second 10,000 is better than third 10,000. Are you getting it, sir? So if you directly add 10 plus 10 plus 10, total 30,000, you know what you are doing? You are giving an equal value to all the 3 cash flows. That is the reason why you should not add them directly. Clear, ma? So what you should do? You should discount them to today. The moment you discount them to today, considering that rate, let's say you are getting an amount of 868. Random, how I got and all, we will see. That's part of this discussion further. This is your NPV. Now, NPV means not just a formula, sir. The moment we say any cash flows, any kind of decisions, your mindla timeline should come. Where am I standing? Where is the cash flow standing? And where I want them to go. By doing this, what you understood, whatever 2 points we wrote, 2 points application is there in this. Carefully see. This are standing at different points of time. But after I add them, what did I do? I brought everything to today. And then I have added, correct? And then I got a lump sum figure of 24,868. And then I have to deduct. But if I have to deduct inflow, outflow, they both also should be standing at the same point of time, and therefore I can do this adjustment also. Am I clear here, sir? So this is your basic point of time value of money. Now coming to further discussions. Sir, this I am discussing with you just for basic understanding purposes. As such, simple interest concept is not used at all, unless the question specifically tells you, which in 99.9999% you will not see it at all. But as such, for general discussion purpose, I am telling you this. Simple interest means something like this. Suppose your investment is 1,000 rupees today. Interest rate is equal to 10%. What it means is, for the 1,000 rupees what you have invested, at the end of first year, your interest cash flow will be 100. 1,000 into 10%. Second year, your interest cash flow is still 100. 1,000 into 10%. Now, like that it goes on. The point is, when I compute first year ka interest, you don't see any problem. But when you come into second year ka interest, you tell me, is this right or wrong? Why wrong? Now, why it is wrong or right depends on whether this interest is actually paid to you or not. First year ka interest is how much? 100 rupees. If it is paid, then how much you have invested till now? Firstly, you have invested 1,000, but you have received 100. So your original investment is intact like that only. On the 1,000 only, second year also you are getting interest. Then there is no problem. But imagine this is unpaid. If this is unpaid to you, what it means is your 1,000 initial investment plus 100 rupees. Total your investment now is how much? 1100. Ideally, you should be getting interest on 1100, but they will not give you on 1100, they will give you only on 1000. This is called as simple interest concept. Simple interest, like interest on interest will not be there. So, there is no interest on interest. Unpaid. Interest is equal to principal amount into interest rate. That's all, sir. This is all the only formula you have to understand. This is simple interest concept. Interest is always computed on principal. There are no applications this concept. Now, since we are learning time value of money from the basic, so I ought to tell you, so I told you, but as such, while doing questions and all, this story will not appear to you at all, nowhere. So, simple interest concept is just for general discussion. Now, coming to the main aspect now. Compound interest, or you can call it as compounding. Now, what is the meaning of the term compounding is? So, compounding is equal to converting a present value into future value. A present flow or some cash flow, if you want to convert that into future, a process is called as compounding. Now, compounding ka most important aspect is compounding involves calculation of interest on initial investment plus interest accumulated till end of previous period. So you have to apply interest rate not on the original amount but on the accumulated amount. Now, coming to compounding a formula. Future value is equal to present value into 1 plus periodic interest rate whole power n. Now, a periodic interest rate, I can simply call it as interest rate also, but there is a reason why we are calling it as periodic interest rate. You will understand that. Now, let's take a small example. ₹1,000 is your investment today. Interest rate is equal to 10% per annum. First year, second year, third year, 3 years is enough. Tell me, sir, what is the interest for the first year ending? 1,000 initial investment into 10%. So that will be 100. So by the end of first year, what is the value of your investment? 1100 plus your initial investment is 1,000. So total value is 1100. When you want to compute interest for the second year, on this you have to apply 10%. So that will be 110 plus your investment now is 1100. Total it is 1210. When you want to compute interest for third year, you have to apply on 1210 10%. So it will give you 121 plus your 1210 already there investment. So total it will become 133. Correct. Now, if you broadly watch on this, am I computing interest on interest or not? Interest on interest is getting computed. Definitely this is called as compounding. Tell me, in this entire timeline, which one is present value, which one is future value? 1331 is future value, 1210 is also future value, 1100 is also future value. There is only one present value. Who? 1,000. Except 1,000, every other number is a future value only. Suppose I say that I want to work out the future value of this 1,000 rupees 25th year, not third year, 25th year I want to work out. What should I do? Draw a bigger line? Huh? No. So we need to establish a relationship between present value and future value. That relation is a formula, sir. Okay, so if I instead of doing all this, I could have done like this. Future value at the end of 1 year is equal to, what is the formula? Present value 1,000 into 1 plus periodic interest rate. What is the interest rate? 10%. Always remember, sir, whenever 1 plus interest rate is there, since it is 1, interest rate should be applied on 1 rupee. So 10% applied on 1 rupee is how much? 0.10. So you should write only 0.10. Interest rate by default always should be written in decimals only, sir. Wherever 1 key interest rate is attached, R should be in decimals. 100 if it is attached, in full number you can write. So since you want future value at the end of first year, whole power 1, so it will be 1100. If you want at the end of second year, then it will be 1,000 into 1 plus 0.10 whole square, 1210. Third year, 1210 into 1 plus 0.10 whole cube, 1331. So that's how you get your numbers directly. Tell me, sir, by the way, just asking, 1 plus 0.10 whole cube, how are you solving this? On calculator. First you wrote 1.10, after that into equal to this answer, whatever comes here, this is 1.10 whole square, correct? One more equal to 1.10 whole cube. So that's what everybody did. You have any other technique with you? On all calculators it's working or not working? Working. Pakka, every calculator. If it is not working in any calculator, let me know. Some calculator won't function. I'm not joking. Stupid people, I'm saying that some calculators do not work. For that, different formula, different function has to be applied. Okay? If it is working, it's fine. If it doesn't work, let me know. Okay, this is about future value. Now, similarly, if I ask you future value at the end of 10th year, what will change? Whole power 10 will come. That's all. Clear? Now, you tell me, sir. I wrote this formula, but I did not tell you what is n. What is n? Yeah. N is equal to, actually in the textbooks if you see, n is called as number of periods. That's what they call, or number of times of compounding. Never remember it as years. N is not years. It coincidentally can be years, but remember it as periods. Okay, now tell me, when I ask you future value at the end of third year, what are we doing? 1000 into 1 plus 0.10. My thinking how it should be is, I am computing interest once in every 1 year. So in a span of total 3 years, how many times will I compute interest? And therefore it is 3. Or in your timeline, go and count how many periods are there. 1, 2, 3. Like that. Not because it is 3 years n is equal to 3. No. For example, I'll change the question now. I'll tell you that this is a half yearly compounding. Interest is computed once in every 6 months. Then when will you compute interest here? You will compute here. Here. So let me write again. 1. I'm sorry. First time I'll compute here. 2, 3, 4, 5 and 6. So how many periods are there? 6 periods are there. N will be equal to 6, but number of years is only 3. So do not remember n as years. Remember n as periods. If interest is computed annually, then n is equal to years only. If it is computed semi-annually, quarterly and all, then it depends on how much length of the period you are having. Okay. So that into how many times you are computing interest. So that's why you only remember it as periods. That is always safe to remember it as number of periods. Right. Now, in the above example, interest is calculated once in each year. This is called as annual compounding. Sir, our entire time value of money discussions lo compounding concept and its applications are very less. Most of our discussion and application, 90% of our entire SFM subject is about discounting, sir. But here and there compounding suddenly will come, and compounding sets up the base for your discounting. So that's the reason first we are covering compounding, sir, because this is the entire base, but application wise discounting is more than compounding. Anyway, let's go into this. Annual compounding. Interest can also be compounded semi-annually. What is the meaning of semi-annually? Instead of computing interest once in every 1 year, we'll compute interest in every once in every 6 months. You can do once in every 3 months. You can do once in every 1 month. You can do it daily. You can do it continuously also. Continuously means smallest fraction of time. Let's say second. So I gave you 1000. On this 1000, you will compute interest for the first second. Add it to the 1000. On this combined amount, you will compute interest for the second. Like that it goes on. This is called as continuous compounding. So semi-annually, quarterly, monthly, daily, and even continuously. I have given a small example here. The example I will solve it now. If you can write, otherwise watch this. It's better if you write. Sir, this fellow Mr. A what he has done is, he invested 1000 rupees, sir, today at the rate of 10% per annum, 12% per annum for 2 years. Now that he invested it for a period of 2 years, the question requirement is work out the future value at the end of second year. Compute the value of deposit at end of year 2. So we have our formula, future value, present value formula. In that you dump it, answer will come. If nothing is given, what will we assume? Interest is computed once in every 1 year. Therefore, annual compounding is what you will assume if nothing is given. But here, we will see all types of compounding. Case 1. Sir, it's not at all about getting the answer. It's about understanding the concept behind it. So be careful. Now, annual compounding, what it means is, interest computed once in every 1 year or each 1 year. So this is the meaning of annual compounding. If you look at the formula what we wrote for future value, present value, we wrote future value is equal to present value into 1 plus periodic interest rate. So therefore, 1 period is equal to 1 year. Since 1 period is equal to 1 year, so periodic interest rate is equal to 1 year interest rate. Periodic ane word ki I substituted 1 year, that's all. And 1 year ka interest rate is given as 12%, or I am writing it as 0.12. Next, in a span of 2 years, there are 2 periods of 1 year each. I hope you agree with this. In a span of 2 years, there are 2 periods. Each period ka length is 1 year. Now you are fit to apply the formula. Future value is equal to present value into 1 plus PIR whole power n, which is equal to 1000 into 1 plus 0.12 whole square. Sort out this, sir. $1.25 for 1254.40. You understand this? Now, you need not write this as such, you can visualize this. That means you invested 1000 here. At the end of first year, on that interest is computed 120. Your original 1000 is there like that only. Total it became 1120. On this 1120, again we computed interest at the rate of 12%. How much is that? 12% on 1120? 134.40. Right? So this is how we visualize this. Fine. Annual compounding is easy. Let's move on. Semi-annual compounding. What this means? It means interest is computed once in every 6 months. So interest is computed once in every 6 months. Therefore, one period is equal to 6 months. And periodic interest rate ka meaning is 6 months interest rate. Sir, 6 month interest rate, how will you get? How will you get? 0.12 is how many months interest rate? 12 months interest rate. So what you do, divided by 12. 0.12 divided by 12 will give you 1 month interest rate. I want 6 months ka interest rate into 6 months. 0.0. That's it, 0.06. Then move on. In a span of 2 years, there are, tell me sir, how many periods? 4 periods. The future value is equal to 1000 into 1 plus 0.06 whole power 4. How much is 1.262477? 1262.47. Normally, sir, 2 decimals will be sufficient. Now that we are doing compounding effects, just to show you, I'm doing this. If you observe the final answers here and here, how much did you have? 1254. Whereas here you are having 1262. Isn't it higher? Clearly 6 rupees, 8 rupees it's higher. Why is it higher? Why is it here? What's the reason for this? The more times you compound, what is happening? You are computing interest on interest also more times. Now if you observe here, did you compute interest on interest? Yes, we did. But for one interest only got compounded. First year ka interest ki second year on first year ka interest amount, second year lo you earned interest. So interest on interest is computed only once. Whereas when you take a half yearly picture, half yearly compounding, it will be like this. 0, 6 months time, 12 months time, 18 months time, 24 months time. So this on our timelines, this is becoming 1, 2, 3 and 4. So on the 1000 rupees what you invest, effectively 6% interest, which is rupees 60, and you have your 1000. 1060. On 1060, you will compute 6% again. Again, you will club it. On that, again, you apply 6%. Again, you club it. On that, again, you apply 6%. If you observe, sir, interest on interest is getting computed how many times here? 1, 2, 3. Here, interest is getting computed. Interest on interest is not getting computed. Are you getting it, sir? So that is the reason. Or else, let's easily make you understand instead of doing the whole thing. Tell me this 1060. Yeah. 63.60. 1123.60. Watch this carefully, sir. In the previous timeline, if you check, by the end of first year, how much is your cash flow? Now, first year means after 2 periods, sir. That is 1123.60. How is it higher? How much is it higher? 3.6. What is 3.6? 60 rupees means 6% only. No, 3.6 is. That means what? Because of multiple times of compounding, interest on interest is getting accumulated, and that is magnifying the future value. That is the reason more times compounding, higher the future value will be. So, case 1 annual compounding answer, case 2 semi-annual compounding answer. Very clearly semi-annual compounding will give you higher future value than annual compounding. Fine, let's move on. Case 3. We can do quarterly also. I'm directly taking you to monthly compounding. So interest is computed once in every 1 month. Since interest is computed once in every 1 month, one period is equal to 1 month. Therefore, PIR is equal to 1 month interest rate, which is equal to 0.12 into 1 by 12, 0.01. So interest rate is ready. Move on. In a span of 2 years, tell me, sir, how many periods are there now? There are 24 periods of 1 month each. Therefore, n is equal to 24. The future value is equal to 1000 into 1 plus 0.01 whole power 24. Can you work it out for me? How much, sir? 1 point, sorry, 1 2 1269.73. Fine. 7346 also, if you read, it will be fine. Chalo, okay. What did you observe here? E number, since it is monthly compounding, every month you compute interest, it gets added to next month. It gets added to the investment. Again, next month interest is computed on the whole amount. More times compounding, future value also will be more. So you can see it's 1269. What is the previous answer? 1262. It became 1269. So definitely it is increasing. Monthly is over. Case 4, sir. Daily compounding. Tell me the meaning of this. Interest is computed once in each day. Therefore, one period is equal to 1 day. Now that one period is equal to 1 day, periodic interest rate means it's 1 day interest rate. So that means 0.12 is for 1 year, 365 days. I want for 1 day. So it will be 0.12 divided by 365. 0.00032876712. This is my PIR, sir. Next. In a span of 2 years, there are how many periods? 1 day, 730, no, 730 periods, huh? Therefore, n is equal to 730, which now means future value is equal to 1000 into 1 plus 0.0003287671 whole power 730. Solve this. Whole power 24 you did. You can do whole power 50 also. 730 is little too much. So we have to find some other technique for this. Some other technique. So we'll pause this calculation here. Then we will learn the technique and come back. Tell me, sir, what is 2 cube? 2 cube is 8. Okay. So 2 cube I want. You are saying it is 8. How will you prove me? 2 into 2 into 2. On calculator also it will come 8 only. Check once. Okay. Okay. You are right. 2 cube is 8. But we will get the same 2 cube in a different way. So just do along with me, sir. Write 2 on your calculator. Square root it 15 times. 2 is the base, okay? Square root it 15 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. How much are you having? 1.40s, 2115339. You are having that? Right. Move on. Step number 2. Two minus 1 is equal to. Right. Step number 3. Multiply with the power, sir. It is into 3. Of course, you have to press equal to also. Step number 4. What we will do is we will roll back the steps. Earlier we minus 1. Now you plus 1. How much are you having? 1.40s, 6346017, right? Step number 5. Do not do step number 5. Watch first, understand it at once you do. So tell me, first step what did we do? We squared it. Squaring means, do you understand it's whole power 1 by 2. Square root of something is nothing but whole power 1 by 2. Nullify that. How to nullify? Square it. You understand, if you square something in a square root, a square root and square will die. You understand, sir? So how to square root it? How to square it? Into equal to square. Like that. Since you did this 15 times, now do this also 15 times. Into equal to means into equal to. Adi 1. Again into equal to 2. Like that 15 times. Not into equal to at once. Not like that. 1, 2, 3. After doing it for 15 times, you should be having your answer as 7.9996. Some number you will get. Isn't this 8 only? What's the moral of the story? 2 cube we can work it out as 8 even under this model also. Sir, but it is not perfectly 8, no sir. Perfectly 8 will not come. But almost 8 will come. Ah, no sir, I want 4 decimals. Instead of 15 times, do 20 times. Then another 2 9s will come, if that is your problem. Okay. So some people actually they stop this at 12 times only. I only do 15 times because 4 decimal accuracy I will get. That's the whole point. Now, if I ask you to work out this, tell me, sir, how will you do? 2 power 0.30. Normal calculator, it will work. It will not work. You need logarithm for this. But 2 power 0.13, 2 power 0.30, you can work out using this technique. Where step number 3, instead of multiplying with 3, you will multiply with 0.3. You will get the same answer. Sir, whether it is 2 cube, whether it is 2 power 30, whether it is 2 power 1 by 5, whether it is 2 power 0.25, 2 power 0.30, it will all take the same time. There is an advantage for this. Okay? Now what we will do, we will apply this logic and try to compute this one. Sir, can we use this in the exam? Of course you have to use. How will you get answers otherwise? You know your study material, I'll show you questions later on. CMS study material, what they have done is, when this kind of things have come, they wrote Excel sheet la formula. They identified some cash flows is equal to IRR brackets opened and selected that and wrote an answer. How can anybody write that kind of answer in study mat, sir? For your exam, computer is allowed, not allowed, no. So how will you get? You have to get your own technique. You can't apply Excel sheet ka formulas in exam, no sir. If you are writing exam in Excel, then that works. Otherwise, how will it work? So we need to have our own techniques. So this will work. 100% accepted. Now come and solve this. Once you have written this, if you have understood this, apply this for this. What is your base here? 1.00032876712. Square root it 15 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Minus 1 is equal to into, who is a power? 730 is equal to plus 1 is equal to into equal to 1, 2, 4. So I am having a number of 1000 into 1.270847. That's enough, sir. Hands are paining. 1270.847. This is my final answer under daily compounding. And you can very clearly see daily compounding answer will be better than your monthly compounding answer. Monthly compounding answer was how much? 1269. This is how much? 1270. Very clearly 1270 is better than 1269. A 1 rupee difference. That's because of your daily compounding. Sir, the more times you compound, obviously future value will increase. But mathematically, if you can understand this statement, more the number of compounding, higher the future value will be, but the increase in future value will be decreasing. Future value will definitely be increasing, but the increase in future value will be decreasing. What's the meaning of this is, look at first case. Your annual compounding answer is how much? 1254. Semi-annual is how much? 1262. That's something around 8.47 difference roughly. Okay, 8 point something. But when semi-annually became monthly, here 1262, this is 1269. 7 rupees only the gap came. But when you do this, hardly 1 rupee gap. Definitely future value will be higher, but the rate of increase will be at a declining phase. Sir, why like that, sir? Why like that means you are computing interest more times, but don't you see interest rate is falling down? How much interest rate did you consider for annual compounding? 12. Whereas here you considered only 6. Monthly it became 1 and daily it became even smaller. Though the number of times of compounding is increasing, interest rate is decreasing. Because of that, future value will increase at a decreasing phase. For this one, graphical story and all is there, but that's not relevant for us. Case number 4. Last case, sir. In compounding. So it's the story of continuous compounding. Now, continuous compounding, what will happen is, interest is computed once per smallest fraction of time. Tell me, sir, in our general usage, what is the smallest fraction of time? General usage, second, right? If I tell you that I am investing 1000 rupees for a period of 2 years, interest rate is 12% per annum, but interest is computed for every second. What is the future value at the end of second year? Sir, in a single day, there are 84,600 seconds. Imagine in 1 year, imagine in 2 years. Number of periods will be very, very, very large. And when you check the previous case, did you observe interest rate for a daily basis? How much was it? 0.0003287. That's daily. That if you divide with 80,000 chiller, it will become even more smaller. That means your interest rate will be as small as 0. It is not 0, but it is almost near to 0. And your n, number of periods, is very large, very, very, very large. And all this discussion assuming that second is the smallest fraction of time, but in fact second is not. Milli, micro, nano. Are you understanding, sir? Continuously means the gap is not there. It's like a tap of water. A torrent flows like that. Continuously interest is computed, added, again computed, again invested, again, like that. So because of this, what will happen is, interest rate becomes extremely small, near to 0. It won't become 0, near to 0. Number of periods becomes extremely large, near to infinity. Because of this, what problem you will face is this one. The formula will fail now. The formula will not work. Why this will not work is, n ka power is how much now? Infinity. Step number 1, 2, 3, 4, 5, step number 3 have to multiply with infinity. That is not possible, no. Hence the formula fails. So then what to do? So we compute future value using exponential series. This is a mathematical application, sir. This is called as exponential series. Now, and consequently, your formula will get modified like this. Future value is equal to present value into e power rt. So what place lo what came? 1 plus PIR whole power n place lo e power rt came. Okay. Careful with this formula, sir. E formula is a little dangerous one. You will have applications of this. Entire derivatives almost is based on this. At that time, suddenly you cannot become knowledgeable. You have to learn now only. Now, E value, no sir, E is called as Euler's number. Its value is 2.71828. book also I think I have given this. Yeah, 2.71828. The Euler's number. Actually, if you Google it, just interesting fact, just type in Google E value, whatever link comes, first link you click off. You scroll the pages, this is an unending number. It's not 2.71828. It's more. You scroll more, number will again come. Last dots will be there. You scroll more, it just keeps on coming. There is no end for that. It's a very large number, large decimal. That's E value, sir. Next, the most important here is R is always interest rate per annum. It is very, very important. Guys, this is very important. Please be careful while using continuous compounding. There is no concept of PIR. PIR concept is for normal formula. When you come to continuous zone, R always should be per annum only. Of course in decimals, but per annum. So if I tell you that I am investing for 6 months continuous compounding, you will take 0.5 there. Sorry, 0.12 only there. You are not going to take 0.06. That is wrong. Don't take 0.06. It will be 0.12 only. R always will be per annum interest rate only. Even if you are investing for 3 months also, 6 months also, 9 months also, interest rate will always be on per annum basis. Sir, but if I am investing for 6 months only, then how can you take per annum basis? For that, adjustment will be in T. T is time period in years. T is time period in years. Now, let's apply our caseless story here. So, future value is equal to 1000 into e power. R is how much here? 0.12. What is it? T? How many years? 2 years. So, which means it's 1000 into e power 0.24. Now, the next question is, sir, how will I compute e power 0.24? Now, you see, sir, generally, whenever e values are given, questions will give you that number. You need not worry that. But as such, in any worst case scenario, the question does not give you that. You have your technique to work out that. How? How means e power 0.24. What is value of e? 2.71828. 2.71828 whole power 0.24. Don't you know how to solve this? Step 1, 2, 3, 4, 5. Apply that. Take the base, square root it 15 times, minus 1 into power plus 1 into equal to into equal to into equal to. And to get the value, you can easily get. Solve it. Yes, sir. How much is the answer? 1.127. I'm sorry. 1.27. 125. Fantastic. $1271.25. So again, you can compare this with your previous answer. Previous answer is daily compounding answer. Daily compounding answer was how much? 1270. This is how much? 1271. Slightly higher now at least. This is how it works. Now, sir, I literally made you work out e power 0.24 now. Okay. Now, sometimes instead of this, we can watch exponential series tables also. If the question gives you that. Now, this will be part of your time value of money table, sir. But anyway, it will look like this. Just watch this. There are columns of x. ln of x. ln means natural logarithm. What is the meaning of this? I will tell you at the right time, sir, while doing something called as a Black-Scholes model in derivatives chapter. E power x and e power minus x. Now we want e power 0.24. A x column lo wherever 0.24 is there, go search there. So 0.24 is here. $1.27125. That's how it is. Am I clear here? Did you get correct answer only? No, sir. The technique work wonders, sir. Whatever 15 times square root is there, I'll give you perfect answers. Table is there, we'll use it. Not there, then we'll work out on your own. I'll tell you where the problem comes with the table also. So for example, in this scenario, you are having e power 0.24. The table available, I will see. You want e power 0.25. That also available. But if you want e power somewhere in the between 0.2425, that will be confusing. 2415. I want this. Table won't give you answer for that. Table won't give you answer for that. But your technique will give you. 15 times square root minus 1 into power plus 1 into equal to, you can work out. Perfect answer you will get. Are you understanding, sir? That is the advantage of the technique. As such, if the question gives you e power, nicely we will use. If it doesn't give, we will work out on our own. So fine, sir. This is about your continuous compounding story. Now, so what we have covered till now in the concept book is, we covered the basic introduction of time value of money, proving that money has a time value. And then comparison key, addition key, subtraction key, we should ensure that the cash flows are standing at the same point of time. Then relation between future value, present value is future value is equal to present value into 1 plus PAR whole power n. And we went into compounding a story. We have started this example where we have seen annual compounding, semi-annual compounding, monthly, daily, and even continuously. Up to here we have covered. There is another formula for computing e-value, sir. Don't use that, that is lengthy. I have method 4, method 5 also, but trust me, sir, this is the most easiest one. Doing it from calculator. Doing it from table is always not in your hand. No, you are not allowed to carry a table. The question gives, it gives, otherwise it doesn't give. So anyway, do this question example also, and then we will move on. If rupees 50,000 is invested at an annual rate of 12% compounded continuously, okay, calculate the value at the end of 6 months, 1 year, 2 years. Hello, sir, do this all of you on your own. Don't see and solve, or don't do auditing. Work out. What is the formula? Future value is equal to present value into e power RT. So, case 1. You are investing for how many months? 6 months. 50,000 into e power R. At what rate is investing? 12%, 0.12. For how many months? 6 months. T is what? T is time period only, but in years. 6 months is how many years? 0.5. Sir, 6 is easy, we worked out. If you ask 2, how can we say? That's why do 6 by 12. If you do 6 by 12, months gets converted into years. That will be 50,000 into e power 0.06. 50,000 into now e power 0.06 ka value. You can work out, sir, or you can check the tables also. E power 0.068 ka value, e power 0.06 ka value is 1.06184. Even if you work out on your calc, 100% you will get same answer. You can try on your own. So 53,092. You got this? Case 2. He is asking you to assume that you are investing it for 1 year. Guys, if you are investing for 1 year, what will change in this? T, instead of 6 by 12, I'll directly write 1 year. So 50,000 into e power 0.12 it is. So 50,000 into 1.1275, 1.1275, let's see, table. 1.1275. You can see the tables here, you can work out on your own, whatever is comfortable, do that. That's 56,375. Next, he wants future value for how many years? 2 years. So that would be 50,000 into e power 0.12 into 2. E power 0.24. Already e power 0.24 we worked out, I guess. Previous example is number 1.27125. Sir, I hope you are able to follow. Now tell me this. When you apply normal formula, which is future value is equal to present value into 1 plus PIR whole power n. Now, if you take this scenario, first scenario, 50,000 into 1 plus. Since this fellow is investing only for 6 months, I have to take interest rate also for 6 months only. That will be 0.12 into 6 by 12. So 50,000 into 1 plus 0.06. Observe here, e 0.06 here also it is there. Even though you are taking per annum interest rate, you are multiplying with 6 months there. At a 0.5 you are multiplying. So what is happening? A per annum interest rate is getting converted into 6 months interest rate. But of course, it won't give you the same answer because it is normal compounding, sir. This is continuous compounding. Answer won't be same, obviously. And I'll tell you one more small thing. Some people, what they do is, creatively, e power 0.06 is nothing but the answer will be 1 plus e power 0.06. 1 plus 0.06 is how much? 1.06. They will use it off as a substitute there. Don't use like that. If you do 1 plus the power, you know what you are doing indirectly, you are doing normal compounding. When the question is shouting about continuous compounding, how can you do 1 plus whole power? 1 plus power if you do, you will not get continuous compounding effect, you will get normal compounding. That's as good as doing present value into 1 plus PIR. Some people use this one as a substitute for this answer. Don't use that. If you use that, it is as good as you are doing normal compounding instead of continuous compounding. A risk is there. Of course, there are some extremely rare cases where your answer will be like, means your requirement will be like this, e power 0.00015. That power is too small. In that case, yes, you may use it. You can call it as 1 plus 0.00015 1.000. And no sir, I don't like this, I'll work out all 5 steps. Work out, you'll get same answer. Means you'll get a bigger answer, but you will not write so many decimals. No, so in that case, extreme cases you can use like that. But as such, don't make any exceptions and practices. Just work out e value as usual and try to work out. So guys, that's the end of our compounding discussion, sir.